So why am I not wearing gloves? That's a good point. I'll get to that in just a minute. So, for you guys who just came in, we are dealing with liquid nitrogen today. And I'll explain even more about what that is too. And this is what it looks like if you guys can see down here. Looks kind of like water, doesn't it? Yeah. Like, can you see it there? Yeah. You guys see it back there? Yeah. Just looks a little bit like water there. Okay. Now, it is very, very cold, as these guys noticed down here. They noticed the little cloud of it makes it very cold. It's actually so cold that the bubbling and the popping in there is the liquid nitrogen actually boiling. It has a boiling point of, well, very, very cold. We'll talk about how cold in a second. But it is so cold that it'll evaporate almost instantly when it comes into contact with something much, much warmer than it, like the air in the room causing it to boil, or, for example, the floor right here. So this is what it looks like when it evaporates very quickly. You guys watch your toes there. Yeah, and it makes that nice little cloud, and you guys down in the front, you can feel how cold that is. Right, yeah. And you see my scooper it's not smoking, it looks like smoke, but it's actually making clouds is what it's doing. Hi guys. So let's talk about how cold something has to be to do what that just did. Do you guys know how cold water is when it turns into ice?
Yes.
How cold? 32 degrees Fahrenheit. Does anybody know what in Celsius? 0 degrees Celsius, right. We'll talk about both temperatures in here, but in science we like to use the Celsius temperature scale because it's a little more accurate for what we do. So water freezes into ice at 32 degrees Fahrenheit or 0 degrees Celsius. Nitrogen, which is the gas in the air, it's all over the place right now. If you guys breathe in real deep, do that with me. Breathe in. And breathe out. Do one more time. Breathe in. And breathe out. Yeah, all right. So that's a lot of what we breathe is nitrogen. About 73% of the air we breathe is nitrogen. That's a whole lot. But we breathe oxygen too, and we know that that's really important to us. But the nitrogen's out there too. And to make the nitrogen gas that's up in the air into a liquid like what's inside here, we have to do what? You might know? Make it cold, right? We have to make it really, really cold. So how cold does it have to be before the gas nitrogen will turn into a liquid? Any guesses? What? Negative 300, you said? You're very, very close. Yeah.
Negative 400?
Oh, that's a little too far. Even closer, yeah. It's about negative 320, negative 325, right around in there. Fahrenheit. Now in Celsius, that's negative 196 degrees. Okay, and that's what compresses the gas into a liquid, like what we see right here. And so we saw that it's cold enough for it to evaporate almost instantly when it hits the floor like that. So let's see what it does to something like an elastic tube like this here. So it's like surgical tubing, and it is nice and stretchy. I need a couple of volunteers to help me out with this one. How about you? And how about you guys just stand on either end of the table, and I've got some safety glasses here too. If you guys will put those on, I'll put mine on here in a second too. We just don't want anything to splash in your eyes, which will bring us in a second to our blood question here. Okay, take it into that. Let me take the other end of that. Okay. And you guys stretch that out for a second. Let's show everybody how stretchy this stuff is, okay? Don't let go. Don't let go. It gets nice and stretched. Okay, so that stretches out pretty far like that, right? Okay, you guys come back in close to the table here. What we're going to do is hold on to your end, and I'm going to take the middle, and we're going to put it inside the liquid nitrogen in here. Okay? You guys can step in a little bit closer. All right, like that. And I'll put my glasses on here too. Doesn't that help me slide out? All right. Yeah, mine are cool and yellow. All right. Okay, so we'll let that sit in there for a minute. Now, what happens to things when they get really, really cold?
Why? They're going to break?
They're going to break. They can break. Yeah, yeah. What else?
Frozen.
They're frozen, right. What else?
They're frost.
They crossed over. Yeah. So what happens inside of things that makes them frozen? Anybody know?
Freeze.
What?
Freeze.
And hard. And they get hard. Yeah, they get hard. So what happens is, in something that's stretchy like this, or a liquid like water, the molecules inside that are kind of loose. They can wiggle around. Now, in gas, the molecules are really loose. They can go all over the place. You get a liquid, they get a little bit closer together. And as you freeze a liquid, or something that's stretchy like this, those molecules start to pack closer and closer together. They try to stay warm. Just like you guys, when you go to school in the wintertime and it's cold and you pull your jackets real close, so you huddle up close to your friends, you're trying to stay warm. The molecules do the same thing. They get packed real close together until there's no space in between them, and they become more of a solid. That's what happens when water freezes into ice, like that. Okay, so when something stretchy like our rubber tube inside here, the molecules start to pack real close together, and, okay, now you guys back up again, let's stretch that out again there. And we see that we have no more stretchy in the middle. The molecules are packed close enough in there to make it more of a solid. Now, if we really pull on it, you can start to stretch that out, but if we pull too too hard, that could break because it is frozen like that. And over time, it'll warm up and start to stretch out a little bit, as we see right there too, like that. But it'll hold that shape until it warms up, and you can see the clouds forming around it and the frost forming on it too. And it is nice and solid over there now, frozen solid there. Thank you very much, girls. You can put your glasses back on the table. All right, and we'll let that sit there to cool off. Not cool off. And we'll see that it slowly regains its stretchiness. That's not where it is. There we go. Yeah, so slowly it starts to regain its stretchiness because remember, this stuff is negative 325 degrees, and in this room it's probably around 70 degrees or so. So that's quite a big difference in the temperature. So that'll stretch back out and get nice and stretchy there. That, okay, so it'll do that to a rubber tube. What will it do to a balloon that's all stretchy like that too? Right? Let's find out. We'll take a nice little scoop full right here. We'll put our balloon inside there. Like that. Okay. Yeah. Okay, so let's talk about our glove question real quick. While I'm sticking my hands inside there. So the question was asked, why am I not wearing gloves? Yeah, that's a very good question. Because this stuff is dangerous. As cold as it is, it could do some damage. If you touched it, if you put your finger in there for about 3 seconds, you could get frostbite, which is a bad deal. Right there. If you put your hand inside the big bucket like that, fully immersed in the liquid for about 30 seconds, your hand would freeze solid. You have like a popsicle hand. Right? We don't want that to happen, so that's why I don't stick my hand in it very long. But the reason I don't wear gloves is because if a droplet of this or many droplets of this were to get inside my glove and be in there with my hand, it could do some damage before it evaporates. So we don't want to trap it anywhere. That's what happens to you in the winter. Okay, so now we have our balloon in there that's been sitting in there, and we saw before that, like this one, it was nice and stretchy. But now, let's watch what we can do to it now. Okay? Yeah. We can just break it right into a bunch of little pieces, just like that. Yeah, because it becomes very brittle as those molecules pack close together, and then they can break like that. And eventually it'll start to stretch back out pretty quick on the balloon there because it's small and holds heat very well. But you can just snap it right into little pieces, just like that. You could have done the same thing to this too, but I only have one of those, so we got to keep that one not break yet. But the balloon breaks just like that. Okay, so we're talking about condensation. Things are condensing, getting smaller like that, which is also why you see the clouds forming around here too. It's so cold, it's condensing the water vapor in the air into clouds that we can see. And you know it's cold. Well, does anybody know how you can tell that it's cold just by looking at it?
Yeah. The frost.
The frost is a good indicator. Yeah. How else?
The ice part.
The ice part. Yeah. What else?
The fog.
The fog. Yeah. The fog has to go to. The fog is going where?
Down.
Down. Right. And with things that are hot, like if you boil water in a stove, where do they go?
Up.
That steam goes up. Right. This fog goes down. That tells us it's cold. Right. Yeah. And that's a little atmosphere science right there. Cold air is heavier. It likes to fall down to the ground. Warm air rises. It goes up. Like that. And of course we get infinite vibration out of that stuff there too. Yeah. Okay, so with my other balloon, we're gonna blow up my other balloon here. Like that. Okay.
Sounds funny. That sounds funny.
Yeah, that's it. All right. So what did we put inside the balloon?
Air.
Air, right? Lots of air. Okay. So if I put the balloon in the liquid nitrogen, what's going to happen?
No. It's going to, the air inside is going to freeze and.
Okay. So you said the air is going to stay warm? You say the air is going to freeze? Yeah. Who thinks the air is going to stay warm and do nothing? Who thinks the air is going to freeze? Okay. Let's find out. So we have to put this inside here to do that. And unfortunately it doesn't fit. So what we're going to do is give it a little helping hand here. Now remember, things shrink. Molecules get close together when they get really cold. So watch what happens.
It's shrinking. It's shrinking. Now it's shrinking.
So we give it a little aid in getting it to fit inside of the